This is our last video on volume. We're going to be focusing on cubes and spheres, very perfect shapes. So a cube is a rectangular prism. It's just a very specific type of rectangular prism where all the sides end up being the same. So when you calculate that cube volume, you're actually going to use the formula side times side times side. Since they're all going to be the same length, you can just say S times S times S, length times width times height. You're not going to say S times S times S. You're going to say side to the third power. So S raised to the third, side times side times side. That's the most basic formula you have to work with. And remember, it's not 5, it is S. So if you want to write the word side so you don't get confused with the number 5, that's fine. Side to the third power. A sphere has a very specific formula as well. All spheres have a radius, and the radius doesn't matter where you draw it, from the center to any part of the edge of that sphere. It could be out here, it could be down there. They're all going to have that same radius from the center. That formula for it is, you're going to have to know this one, 4/3 pi r to the third power. There is no other dimension, there's no height. The radius is the only thing, just like the side's the only thing for a cube. So those are very specific formulas, and we're going to use those for cubes and spheres. We got a couple examples to work out so we can understand how to apply them. Let's look at the first one. Question 6, you have two balloons in the shape of a sphere. One balloon has a radius that is 3 times the radius of the other balloon. How many times more air will the larger balloon need than the smaller? Well, you can approach this problem theoretically or practically with a number. So let's start practically. We don't know the dimensions. So you have two balloons in the shape of a sphere. One balloon has a radius that is 3 times the radius of the other balloon. So let's take the small balloon here, and let's make up a radius. Let's say the radius is 1 meter. Let's look at the large balloon. Its radius is going to be 3 times the radius. So that radius would be 1 times 3, which is going to be 3 meters. And the question says, how many times more air will the larger balloon need than the smaller? In other words, how many times bigger is the volume? You can think of that question just by rewriting it as how many times bigger is the sphere of the large sphere, or is the volume of the large sphere. So if you take this small balloon, if I put a 1 there, let's say I put a 1 there. Let's see if I can make this dimensionally accurate. So if I go out here, 1, 2, 3. It looks like that's about 3 if that's 1. And if I make my sphere have a radius of 3, that means its volume is going to be a lot bigger than 3 times that. Okay, think about, I could fit a lot of these inside of here. So the question is, how do we calculate that? Well, we could use the formulas. Let's take a look at the small one. So the volume of the small one is going to be 4/3. Remember, the formula is 4/3 pi r to the third power. So if I say 4/3 pi times 1 to the third power, that would be the volume of the small one. And the volume of the larger one is going to be 4/3 pi times 3 to the third power. Now, if you calculate both of those here, you're going to get 2 separate volumes. You could divide them out to figure out how many times bigger the larger one is than the smaller one. So why don't you go ahead and throw that into your calculator, see what you get. If you put those both in the volume formula, you're going to see 2 very different volumes. For the small one, you'd have about 4.188, and the large one, you'd have 113.0973. That's not 3 times as much, because if you take this number here and you times it by 3, you're only going to get like 12.56. So it's not 3 times as much. You can figure out how many times as much it is by taking this number and dividing out this number. And 26.9999 is going to actually be 27. And why is it so big? You got to think about these numbers. So let's write these numbers down first and try to analyze what's going on. So it is 27 times bigger. And, you can ask the question, is that going to work with every number that you plug in for the radius? So if I decide I want my radius to be like 2 and 6, would that still work? We can find that out. doesn't matter, right? If I plug in 2, let's see what I get. So if I plug in 4/3 times pi times 2 to the third power, I get like 33.5. And then if I do the same thing, but I plug in 2 times 3, 2 times 3 is 6, I get 904.77. If I take those two numbers, divide them out, you're still going to be at 27. So no matter what you start with as your dimension, it's going to be 27 times as big. Let's talk about like just formula in the formula why that works, okay? So imagine I threw in r into my formula and I didn't assign a number, and the large one is going to be 3 times as much. So I would call that radius up here 3 times r. Now, when I divide these out to get that ratio, the large divided by small, you'll notice that these 4/3 cancel out, these pi's cancel out. And if I write 3r to the third power, 3r to the third power is 3r times 3r times 3r, which is going to be 3 times 3 times 3, which is 27, r to the third power. So I can rewrite that as 27 r to the third power. And guess what? Those r to the third powers cancel out too. So the only thing I have left on the numerator is 27. That means that volume will always be 27 times as big. Or you can just look at that 3 and say, it's cubic units. It's going from 1 dimension to 3 dimensions. So I'm going to do 3 to the third power, and that's going to be equal to 27. Tricky problem, but theoretically, there's your formula for it, and it's going to be 27 times as much air. So 27 times as much air in the larger one than there is in the smaller one. Crazy, huh? Let's look at another question. Question 7, a sphere is inscribed in a cube as shown below. If the volume of the cube is 216 cubic centimeters, what is the volume inside the cube not taken up by the sphere? This question has a few layers to it. Let's just think about what we have first. We have the volume of the cube. So let's work with that. The volume of the cube is 216 cubic centimeters. The question wants to know what's the volume inside the cube not taken up by the sphere. So if you imagine all this empty space here, that's what I'm trying to find. So we're going to have to know what is the sphere's volume so that we can subtract it from the volume of the cube to figure out what is that empty space. So the question we're trying to figure out is the volume of the empty space is going to be the volume of the cube minus the volume of the sphere. We're given the volume of the cube, so we really just need to get the volume of the sphere and take that away from the cube to figure out the answer to our question. So let's dig into that. Since we know the volume of the cube is, it's all going to have the same length, side times side times side, I know that the volume of the cube, that formula is going to equal side to the third power. And I also know that that's equal to 216 since I'm given that in the problem. So the first thing I'm going to do is I'm going to figure out what side is. And I can take the cube root of 216 to get what each side is going to be. Or I can take 216 and raise it to the 1/3 power. Either one will get you the same value. So in your calculator, whether you take the cube root or raise it to the 1/3 power, you get the same answer. So let's test out and see what we can get for that side. The side length is going to be the cube root. So you can do CBRT 216. Again, that's going to be CBRT cube root. Or you can also do NTHROOT and manually put a 3 there if you want. That's going to give you 6. And remember, that means 6 multiplied by 6 multiplied by 6 is that value. The other way you can get the answer is you can do 216 and you can raise it to the 1 divided by 3. And that'll give you 6 as well. Either one will get you that side. So now we know the side length is going to be 6. So I have my side length. I'm going to write that on the picture so you can kind of get a visual of what's going on. So I'm going to say this now is going to be 6 along each side. And now I want to get the volume of the sphere. I can do that because I know that the whole distance across the sphere is 6. That 6 is actually your diameter. So your radius is what you're trying to find, because the radius of the sphere is what's in the formula. And the volume of a sphere is going to be 4/3 pi r to the third power. 4/3 pi r to the third power. So if I know that that's going to be the center of the sphere, then I know my radius is going to be 6 divided by 2. So the radius is 6, your diameter, divided by 2, which is going to be 3, in this case here, centimeters. So now I can plug that in to get my volume. So it's going to be minus 4/3 pi times 3 to the third power. And now we're pretty much ready to get this all calculated. So let's use our calculator to help finish the job. All right, we're typing that into my Desmos. I'm going to do 4 divided by 3. I'm going to write arrow out of there and then put the pi here, so pi. And then I'll just use parentheses and put 3 in and raise it to the third power. And I'll get a volume of about 113.097. So we'll say about 113.1. Write that down, and then let's substitute the volume that we have for our cube as well. So our volume of our cube, we'll just bring that down. That was given to us 216, 216, and 216. So that empty space is going to be 216 minus that number. Once you do that, you'll have your answer. And you'll get about 102.9 if you can see through my drawings here. So let's write that down, and we'll be done with this video, and you should be able to do all your work now from here on out. So would we say that's going to be equal to 103.9? I already forgot. What was it? Yeah, 102.9, excuse me. So 102.9. And what's our units? Our units is going to be 102.9. And this is centimeters, so centimeters cubed. So the volume of the space not taken up by the sphere is that empty area here, that empty space, 102.9 centimeters cubed. Thanks for watching, y'all. Have a good day.